Okay, so now having finished the Pac-Man assignment, where you're doing this basically, your next task is to actually code Conway's Game of Life um, using similar techniques that you've now hopefully mastered in the Pac-Man assignment. Because the Pac-Man assignment is a multi-dimensional, or uses as a base a multi-dimensional array, or a two-dimensional array. Um, and so does Conway's Game of Life. Here's Conway's Game of Life, and you have a multidimensional array here as well. And if in Pac-Man you are clicking this button and it's moving Pac-Man around like this, in Conway's Game of Life, this you can click this button and the cells evolve over time. But in both cases, you're still using a multidimensional array. Um, so let's go through the. I give you a template that you can use to actually code this, and let's go through that template right now. So first of all, I do provide for you. I actually create the grid, um, uh, and here it is. Here's the grid, and by default, all the cells in the grid in Conway's Game of Life are dead. Um, but then I actually, if you look at the game, at least the way I've set it up, there are, to begin with, these initial cells that are alive. And I actually paint this one for you. So this is the coordinates of the blinker. And your task then is to set one of the initial task is to set the coordinates of the crawler, which are right up here. Just set them just look like that. And then all you have to do with the rest of the template is to search for all the to-dos, and just like here, and write the code that comes after it. So, for example, right here you have to set the coordinates of the crawler. Then below here you have to actually write the code that will execute the print grid function. You should be able to know how to do this based on a similar print grid function that exists in the Pac-Man assignment. Then you also have to write a function here that will count the surrounding live cells of any existing cell, because that's the way Conway's Game of Life works. Remember that in Conway's Game of Life, to determine whether in a next generation a cell is going to live or die, you have to count the number of surrounding cells. So for example, this cell right here that I have my cursor over, it has three surrounding cells that are alive, so that cell would come alive. Now, however, this cell right here, has only one surrounding cell, so it will die, and that's why we see this blinker type action right here down at the bottom. Uh, so you have to be able to count the existing cells. The nice thing about this, though, is that to write this code, you can look at the Pac-Man assignment and see how you counted the number of ghosts that were adjacent to the Pac-Man. So the code here is very similar to the code that you would have in Pac-Man. You have to probably make some minor adjustments. So in addition to writing the count surrounding live cells function, you then also have to complete the evolve function here. And the evolve function is triggered every time you hit the evolve button in the interface. And what it's basically doing is it's scanning through all the cells in the grid. Let's just look at that grid one more time. And it's going from left to right and from top to bottom. So this is the first cell it scans, this is the 10th cell it scans, this is the 11th, and so on until this would be the last cell that it scans. And for each cell that it's scanning, it's looking at the surrounding cells, counting the number of surrounding cells using that function that you also coded, right? This one. Uh, counting surrounding cells, determining the number of live cells, And then, based on Conway's Game of Life rules, the ones that you have in the final interface, these rules, it determines whether the scan cell should come to life or whether it should perish. And intuitively, you would go, okay, well, if a particular cell needs to die, well, let's look again. We look at the code. If, let's say, this cell needs to come to life, intuitively you might go, okay, well, then just update the original grid and make it alive. Well, that would be nice, except that when you come down to this cell and scan it, it would see that this cell is alive when it's actually dead in this current generation, and it would corrupt the scan. So instead of marking the original grid as alive, uh, as that's the cell as alive in the original grid, you would mark it as alive in the copy of the grid, and then only when you've gone through the entire scan do you then take all those marks that you put into the copy of the grid and then copy them back into the original grid. Otherwise, your scan will become corrupted. And that's what this code is doing here. Is um, I provide, I make a copy of the original grid and I call it grid copy. And so as you scan through all the cells in the grid and determine whether each cell needs to come alive or dead, you would put that make the mark in the grid copy, and only after you scan through all the cells do we then copy the grid copy back into the grid and then redisplay or repaint the grid or display it again in the actual GUI. And again, I provide for you all the pseudocode here. You don't have to follow it faithfully if you don't want to. You could try to write it from scratch by just examining, looking at the rules for yourself and figuring out how to embody those rules in code. But I provide for you the pseudocode in this comments here, and you can use it if you like. And that's really basically the assignment. Even though I should say finally, even though this evolve function, I've put it down below the count surrounding cells function, you could, you might, I don't know. I think I might be inclined to write this function first, or at least parts of it. Um, and then, I mean, it does ultimately depend on count surrounding live cells because you actually call count surrounding live cells from inside the evolve function. But leave it up to you to determine which one you want to write first. Okay, good luck with that.